Lecture of Fundamental of Electrical Engineering. So here today we will solve one maximum power transfer theorem problem. So now as you can see in this circuit they asked find the maximum power that can be delivered to the load. So as you can see in this figure, this is the max RL is the load resistance and it is unknown. So RL is the load resistance, it is unknown, and they asked what is the maximum power that can be delivered to the load. As you know the formula, so if your RL equal to RTH, that means first we need to convert this particular circuit into a Thevenin equivalent circuit. For that we need to remove the load and across the load resistance. So let this node is A, this node is B. So first we need to remove that load. So after removing that load, we will find out what is V Thevenin value and R Thevenin value across this A and B. Okay, so we'll start the problem. So first we'll remove the load here. You can see I remove the load and I kept this node is A and B. So across A and B, I need to find out what is RAB and what is VAB or the open circuit voltage or Thevenin's voltage. Okay, so when we find out this RAB or R Thevenin, so for that what we need to do, first voltage sources will be short circuited and current sources will be open circuited. So by doing this voltage circuit short circuited or current source open circuited, we'll get a figure like this. You can see here. So so here voltage source is short circuited, here also voltage source is short circuited and current source is open circuited. Now across A and B I need to find out what is our RAB. Now you can see here this 3 ohm and this 5 ohm. So same current will flow or these 3 and 5 are in series, and whatever I will get, that is 8 ohms I will get, that will be parallel with 2. So I can write down here 3 plus 5 parallel with 2. So I'll get 8 is parallel with 2. So I'll get R Thevenin equal to 16 divided by 10, that is your 1.6. So I'll get 1.6 ohm is our Thevenin resistance or RTH equal to 1.6 ohm. So once I get RTH, then I need to find out what is VTH or the VAV or the open circuit voltage across the load. So when we need to find out the open circuit voltage, then we need to again put the voltage source and current source in the circuit. So after putting the voltage source and current source, now you will get a diagram like this. So you will get this diagram like this. So now here this in this diagram I have need to find out what is VAB or V open circuit voltage. Now you can see clearly this particular problem. I need to find out VAB. So here you can see that if this node is A, this node is also A, and if this node is B, this node is also B. If I want to find out what is VAB, that means see, I want to find out VA minus VB. That means A is having higher potential, B is having lower potential. That means I can write down this terminal is at plus, this terminal is at minus. I want to find out what is the voltage drop across here. That means what is the voltage drop across this 2 ohm resistance. So voltage drop across 2 ohm resistance, and what is the voltage drop across is 30 volt already given. So by adding this I can find out what is VAB. Now this particular problem I can solve using mesh analysis, I can solve using source transformation, or I can use superposition theorem. So it depends upon you in which theorem you are comfortable. Now for the time being, I will take the superposition theorem to solve this particular problem or to find out what is VAB. Now you can see here, in this particular circuit, three sources are used, two voltage sources and one current sources. One 60 volt voltage source, one 30 volt current source, and one 18 ampere current source. Okay, so now as I am using three different sources, so I need to draw three different diagrams, and I need to find out what amount of current is flowing through these two, what amount of current is flowing through these two, and what will be the drop here. That I need to find out. So first I will take what is the 60 volt. So I have drawn already this diagram. So I want to find out what amount of current is flowing due to 60 volt. Now you can see here the 60 volt. Now this 3 ohm and 2 ohm and this 5 ohm all are in series. So what amount of current will flow? The source current. Source current is nothing but a voltage divided by the total resistance. I am getting I equal to 60 divided by 3 plus 2 plus 5. So I will get 60 divided by 10, that is your 6 ampere of current is flowing. Now 6 ampere of current is flowing here and 6 ampere current is also flowing in this 2 ohm from left to right. So I can write down current due to 60 volt. Current due to 60 volt is nothing but 6 ampere and the current is flowing from left to right. It is very important to give the current direction. Now once I calculated the current for 60 volt, then I can go for next source. So I have taken 30 volt. So when I am taking this 30 volt voltage at that time, all other sources will be open circuited or short circuited, depends upon the what type of source I am using. So when I am taking this 30 volt, you can see 60 volt voltage source will be short circuited and the 16 ampere current source is also open circuited. Now I will get a diagram like this. Now I want to find out what amount of current is starting from this voltage source and flowing here. Okay, so and you can see here, let some I amount of current is flowing started from the 30 volt. It flows through the 5 ohm. Again, it comes through 3 ohm. Then same amount of current will flow through 2 ohm and reaches here. So I can find out what amount of current. The total voltage is 30 volt here, and the resistance is 5 plus 3 plus 2, all are in series. So I can write down directly 10 ohm. So I will get here 3 ampere of current. You see 3 ampere of current is flowing due to 30 volt. That is from again left to right. So I can write down current due to 30 volt. I will get 3 ampere, that is flowing from left to right. Now I am over with two sources. Now one current source left. So I already draw the diagram. So for this 18 ampere, when I taking this 18 ampere at that time, you can see all other voltage sources will be short circuited. Now if you look carefully, this is the current source, and this current for this current source, this 3 ohm and this 2 ohm are in series. So this 5 ohm and this 5 ohm are parallel. So you can see here this 18 ampere of current will start from here. So this 18 ampere of current will start from here. When it reaches here, it can see two paths. One path is going here, that this is your I1, and here it is I2. So in this I2 amount of current will flow through 3 and flow through 2. Okay, so what total amount of current? I can apply current division rule, but I can see here. So this is 5 ampere and this is also 5 ampere. So this is 5 ohm and this is also 5 ohm. So both 5 ohm are in parallel. So current will divide equally. So I can find out the I2 value is, so the I2 value is total current 8 divided by 2. So I can see here I will get 9 ampere of current will flow here. So I2 also 9 ampere of current will flow here as well as in the 2 ohm resistor. So I can write down here current due to 18 amp, current due to 18 amp is 9 ohm, and again this current is flowing from left to right. This also current is flowing from left to right. Now what is total amount of current will flow here? So I can write down I total. So I total is the I due to 60 volt plus I due to 30 volt plus I due to 18 ampere. So what amount of current I will get now? So I will check now 6 plus 3 plus 9. I will get 6 plus 3 plus 9. So total 18 ampere of current is flowing through the this 2 ohm resistance from left to right. So here I can see the I total is equal to 18 ampere, and already there is a voltage source. So if you take, this is your A and this is your B and this is your, you already taken, this is your minus, this is your plus, this is 30 volt. Now you can see 18 ampere of current is flowing through this 2 ohm resistor. So what will be the drop? The current is flowing from left to right. So I can see here current the voltage drop is current into resistance. So you can write down here. So let this voltage drop. So voltage drop here. So current is entering here plus, leaving here minus. So voltage across 2 ohm equal to 18 into 2, that is 36 volt. This is 36 volts. I can write down here. This is 36 volt. But I am interested to find out what is VAB. So VAB, so I'll put this is plus, this is minus. I already written in the beginning. So if I can apply KVL here, I can apply KVL here. So it is open, but I have a voltage. So I apply KVL. I am going also in this clockwise direction. So minus to plus. There is a gain. So I will get down plus VAB. Then plus to minus. That is minus 36 volt. Then again minus to plus. I will get gains 30 volt equal to 0. So I can get here VAB equal to 6 volt. So VAB is nothing but your VThevenin, and I am getting VThevenin equal to 6 volt. So once I got VThevenin, once I got RThevenin, then I can able to write down the equivalent circuit. So I am writing here Thevenin's equivalent circuit, Thevenin's equivalent circuit. So I write down here, this is your VThevenin, this is your RThevenin, and this is your RL. This is your RL. So I got RThevenin equal to 1.6 ohm, VThevenin I got 6 volt. So for maximum power transfer, I can write down our RL must be 1.6 ohm, and what is Pmax? Pmax formula is V Thevenin square divided by 4 RTh. So I can write down here 6 square into 4 into 1.6. So what I will get now? 36 divided by, so by using calculator I can get here 36 divided by 1.6 into 4. So I will get here 5.625 watt. This is your Pmax. Okay, the same problem I can solve using source transformation also. Okay, so in the next video I will discuss about how we can use source transformation. If you think that this video is useful to you, then you can share with your friends, and if you have any problem you can write down in the comment section. So we can meet in the next class. Thank you.